Science fiction movies often show astronauts drifting away into the endless darkness of space. But how realistic is that? What would happen if someone found themselves completely alone in open space? Could they return or disappear into the void forever? And has anything like this ever happened in real life? Let's find out. From orbit, the work of astronauts can look peaceful, floating above Earth, watching continents move below. But the reality is very different. The International Space Station, or ISS, is a huge laboratory orbiting Earth at about 28,000 kilometers per hour. Like any complex machine, it constantly needs maintenance. Outside the station are solar panels, antennas, sensors, cameras, and scientific instruments. Some cannot be repaired from inside, which means astronauts sometimes have to go outside. These operations are called spacewalks. A spacewalk is one of the most dangerous tasks astronauts perform. Astronauts train for months practicing underwater to simulate weightlessness and rehearse every step of the mission, because even small mistakes in space can have serious consequences. Outside the station, astronauts face extreme temperatures, higher radiation, and the vacuum of space. The only protection is the spacesuit, a thin barrier between the human body and one of the harshest environments imaginable. During spacewalks, astronauts are always attached to the station with a safety tether. They also work in pairs, constantly monitoring each other. Even with these systems, risks still exists because space behaves very differently from Earth. On Earth, motion eventually slows down due to air resistance, friction, and gravity. But in space, those forces are almost absent. A small push can send an object drifting for a long time. If an astronaut lets go of the station, they might move away only a few centimeters at first, but slowly the distance increases. Another danger is rotation. A small movement can cause the astronaut to begin spinning. Without something to grab onto, stopping that spin becomes difficult. Now imagine the worst scenario. The safety tether detaches, the partner is too far away, and the station slowly drifts farther away. At first, the astronaut might not notice. There is no wind, no feeling of speed. But after a few seconds, the station begins to shrink, and a race against time begins. The first step is to stop the body from spinning. Then the astronaut can activate SAFER, an emergency propulsion system. SAFER stands for Simplified Aid for EVA Rescue. It is a small backpack with tiny thrusters that allow astronauts to control their movement. By firing these jets carefully, an astronaut can slowly guide themselves back toward the station. If everything works correctly, they can return to safety. But if the system fails or the astronaut becomes disoriented, the situation could become far more serious. In some cases, gravity might slowly pull the astronaut toward Earth. Eventually, they could enter the atmosphere. But that would not mean rescue. Objects entering the atmosphere at orbital speed generate enormous heat, thousands of degrees. Spacecraft survive this with heat shields. A spacesuit does not. Another outcome is more likely. The astronaut would simply continue drifting into space. First, the station becomes smaller, then a tiny point of light, and eventually, it disappears. Inside the suit, there is air and life support, but only for a few hours. When the oxygen runs out, survival becomes impossible. Many people think a body would instantly freeze in space. In reality, freezing would happen slowly, but other dangers appear. One is cosmic radiation, which constantly bombards objects outside Earth's atmosphere. Another is micrometeoroids, tiny particles traveling at extremely high speeds. Even grains of dust can damage surfaces over time. If the spacesuit were punctured, the pressure inside would drop instantly. Despite the risks, spacewalks happen regularly, but sometimes unexpected problems occur. One of the most dangerous incidents involved Italian astronaut Luca Parmitano. During a routine spacewalk, he began to feel drops of water inside his helmet. At first, he thought it was condensation, but the water kept increasing. Soon, it covered his ears and reached his eyes. In microgravity, water forms floating spheres, and that sphere was growing around his head. Eventually, the water drifted toward his nose and mouth. If it blocked his airways, he could have drowned inside his own helmet. The cause was later traced to a leak in the suit's cooling system. Nearly 2 liters of water collected inside his helmet. With limited vision, Parmitano carefully navigated back to the station and survived. The first spacewalk in history nearly ended in tragedy. On March 18, 1965, Soviet cosmonaut Alexei Leonov left the spacecraft Voskhod 2 and became the first human to float freely in space. But when he tried to return, his spacesuit had expanded in the vacuum. It became rigid and he could not fit through the airlock. Meanwhile, his oxygen supply was running out. With little time left, Leonov made a dangerous decision. He reduced the pressure inside his suit. This was risky, but it made the suit flexible enough to squeeze back into the spacecraft. His heart rate reportedly reached 140 beats per minute. Throughout the history of human spaceflight, 18 astronauts and cosmonauts have died during missions. Most accidents happen during launch or re-entry. Among the most famous disasters were the Apollo 1 fire, the Challenger explosion in 1986, the Columbia disaster in 2003. Each tragedy forced engineers to improve safety systems. Over time, spaceflight has become much safer. Living in space affects the human body in surprising ways. Fluids shift toward the head, increasing pressure around the eyes and sometimes affecting vision. Muscles weaken because they no longer fight gravity. Bones also lose density over time. To prevent this, astronauts exercise up to 2 hours every day. Another issue is space motion sickness, similar to seasickness. Fortunately, most astronauts adapt within a few days. Even tears behave differently. Without gravity, they do not fall. Instead, they collect around the eyes and form floating bubbles. From a distance, space looks calm and beautiful. But in reality, it is one of the harshest environments humans have ever entered. Every time an astronaut steps outside a spacecraft, only a thin layer of technology separates them from the infinite void. And yet humanity keeps going there, because the desire to explore the unknown has always been stronger than the fear of the darkness beyond. But what about you? Would you dare to step outside a spacecraft and float above Earth in open space?